Hello everyone, welcome back to the another session in design and analysis of algorithms. The topic name is PNP, NP hard, NP complete problems. This topic you'll find in 5th unit as topic number 2. Now let's get started. In the previous video, we come to know about two things, what are called as deterministic algorithms and what are called as non-deterministic algorithms. So deterministic algorithms are what? Which takes polynomial time and we know each and every working statement. And non-deterministic algorithms are what? The algorithm which takes exponential time, and these algorithms, few steps we know and few steps we don't know, correct? So that case we were seeing in the last video, and this video we'll be going to talk about non-deterministic algorithm which takes polynomial time. Right? Now, in measuring the complexity of an algorithm, we use input length as the parameter. An algorithm A is of polynomial complexity if there exists a polynomial P such that the computing time of A is big O of P of n for every input of size n. And here there are two problems which are NP hard problem and NP complete problem. Now let's understand what you mean by this. The problem that is NP complete has a property that it can be solved in polynomial time, and if and only if other NP complete problems can be solved in polynomial time. So that means now whatsoever problems I listed out in the earlier video, let's talk that polynomial time algorithms or linear search algorithm and binary search algorithm, these will take polynomial time complexity. Now if one of the algorithm is taking polynomial time complexity, all the algorithms what I have listed here will also take polynomial time complexity. So NP complete is what? It is a problem which can be solved in polynomial time. And we do have the other problem which is NP hard problem. It can be solved in polynomial time. Then all NP complete problems can be solved in polynomial time. So this NP hard problem is what? Non-deterministic algorithms. That means the algorithm which takes exponential time, that also will take polynomial time to get completed, right? Because in the earlier case, in the earlier video, we were discussed about this, that if you have some searching algorithm, we go to that statement. Now let's see this one. This is what non-deterministic algorithm, because you know about only few steps. That the few steps are what? If I wanted to search any key element, now let's look at this. I wanted to search some key element in the given set of elements. Before I come to this condition, if I execute this choice, if I pass some arbitrary constant to this choice function, I can write the index of array through the j identifier or through j variable. So here choice is what? It is a function which is working to give very fastly that the index of a variable. So it takes only a constant time, and it is what? Best time. You have two algorithms which gives polynomial time, big O of n and big O of log n. If I have an algorithm which gives me one time, that is of big O of 1, then it is constant time. So I may feel very comfortable to have this complexity in the case of polynomial time. But I don't know what choice function code is. I don't know what the statements are included in choice function. It is unknown to me today. It is unknown to me. So I know only these statements which takes some complexity. Now this algorithm will take some time, right? This algorithm will take some time, and in this algorithm I know only these statements. The algorithm the algorithm which executes in the polynomial time is called as what? Deterministic algorithm. And as I don't know this statement in which time it will get executed, so the whole algorithm is called as non-deterministic algorithm. Now the point is very clear that this algorithm will take polynomial time also, correct? Polynomial time also. Now, so this video will helps you out to understand that we will write polynomial time algorithms. That means we'll not write exponential again because it is waste of time. We will be writing non-deterministic algorithms which is taking polynomial time. And these are what NP hard problems. NP complete is algorithm which takes polynomial time. NP hard problems are algorithm, non-deterministic algorithm which executes in polynomial time. So that is what NP hard and NP complete. Now, so the main agenda of this or the main aim of this is what? We will be going to write non-deterministic algorithm which takes polynomial time. For the problems which are taking exponential time, example traveling salesperson and knapsack problem. So with this we define two classes here. Let us see that two classes. What are those? Those are P and NP. What do you mean by P? P is the set of all decision problems solvable by deterministic algorithms in polynomial time. Example, so a linear search which takes polynomial time, binary search, bubble sort, merge sort, single source shortest path, minimum cost spanning tree, merge pattern, all this takes polynomial time and the algorithms are deterministic. We call the algorithm as P. And we do have the other class, that is what NP class, one more class of algorithm, that is NP. These algorithms are non-deterministic, but they take polynomial time. For whom we will try to write, we try to write for these type of problems. These are exponential, that exponential time algorithms which are traveling salesperson problem, Hamiltonian cycle, knapsack problem, graph coloring. All these algorithms will take exponential time. Now NP is what, or NP class is what? NP is the set of all decision problems solvable by non-deterministic algorithms which takes polynomial time. So now we try to write for these type of problems. These are exponential. We convert them into polynomial, but we don't know how it is possible. So we'll leave the statements non-deterministic. So algorithm becomes non-deterministic. So non-deterministic polynomial taking algorithm. So deterministic polynomial time taking algorithm. So as P and NP. Right? Now we have a relationship in between P and NP. That is what? P is subset of NP. The most important relation. Now the meaning of this is what? The deterministic algorithms we know today were the part of non-deterministic. That means we don't know any sorting algorithm. Let's assume that we don't know any sorting algorithm. If we don't know something, that is called as non-deterministic algorithm. By the time being, people came up with the different kind of algorithms to introduce to us with the different complexities. So whichever is not known one day or yesterday, that are known today. Till merge sort coming into the picture, we don't know what is merge sort. So till you don't know merge sort, it is what? Non-deterministic. The moment when you come to know about merge sort algorithm, that became it is deterministic. So whatever it is deterministic today, that is one day it is non-deterministic. And whatever today non-deterministic, that will convert into deterministic by some research. That means all are non-deterministic algorithms because all we don't know. Very simple logic. All we don't know. Today what algorithms we have, that only we know. So whatever we know are P, Whatever you don't know are NP respective to the algorithms. Whatever you know today, that it is came from the non-deterministic. And whatever you don't know today, let us talk that non-deterministic algorithms which take exponential time, and that algorithms, all the steps you may be not knowing, or the algorithms which gives the best complexity, that also you don't know but today, but one day you will be knowing it. That is what P is always subset of NP. And we'll do some satisfiability problem to find out the relationship in between P and NP little more deep. Thank you all.